In this particular lecture, we will discuss about the hypergeometric distribution and its associated topics. For this distribution, let us consider a box which contains the n balls. Out of that, m are the white balls and m minus n are the red balls. Consider that a sample of small n balls is drawn at a random without replacement from this box. Then the probability of k white balls is given by this quantity, which is equal to this quantity. Therefore, in general, a discrete random variable x is said to follow the hypergeometric distribution with parameter capital N, capital M and small n if it assumes non-negative values and its probability mass function is given by this quantity. Now we will calculate the mean and the variance of the hypergeometric distribution. According to a definition, expected value of x is given by this quantity. After putting the value of p of x, we will get this. Now we just open that mck, which is equal to m by k into of m minus 1 ck minus 1. Then we can write like this. As this quantity is independent of k, that's why we will write it outside that summation. We have this probability mass function. The summing over this probability mass function at k is equal to 0 to small n into p of x equal to 1. It means we can write this quantity equal to 1, or we can write like this: mck into of n minus m, n minus k is equal to ncn. Now write x is equal to k minus 1, small m is equal to small n minus 1 and capital M minus 1 equal to a. Here we will get this quantity. Now compare this thing with this. Then this quantity will equal to this quantity. This quantity will equal to this quantity. As we put the value of small m, we will get this, which is equal to small n into capital M by capital N, which is the expected value of x, or we can say that mean of the hypergeometric distribution. Now for calculating the variance, we need the value of expected value of x square, or we can write the expected value of x square like this, which is equal to this quantity. Now according to a definition, the expected value of this can be written as like this. This is the p of x. Again, like a previous case, we can write like this, all equal to this. After solving, we will get this, which is the expected value of x into x plus 1. Therefore, the variance is equal to the expected value of x square into expected value of x whole square, which is equal to this quantity. After solving, we will get this, which is the variance of the hypergeometric distribution. Now, we will study the approximation to the binomial distribution. Hypergeometric distribution tends to binomial distribution as the value of capital N tends to infinity and capital M by small n tends to p. We know that the probability mass function of the hypergeometric distribution is given by this quantity. After opening, we can write like this or like this. We are just expanding the factorial terms. Like m factorial can be written like this. Now cancel out the terms and divide and multiply by capital N. We will get this term. Now put capital N tends to infinity and capital M by capital N equal to P. Therefore, this entire term can be written like this. Here the P comes K times and 1 minus p comes small n minus k times. Therefore, we can write like this, which is the binomial distribution of k with parameter p and 1 minus p. Or we can write like this, p plus q is equal to 1. Therefore, we can write 1 minus p equal to q. This shows that the hypergeometric distribution tends to binomial distribution as n tends to infinity and m by capital N equal to p. Now we will study the recurrence relationship of the hypergeometric distribution. We know that probability mass function of the hypergeometric distribution is given by this quantity. Now we can write for k plus 1 also, which is equal to this quantity. Just replace k by k plus 1. We will get this. Now divide this quantity by this. We will get this, which is equal to this quantity, which is the required recurrence relationship between probabilities of the hypergeometric distribution. These are the few topics related to the hypergeometric distribution. I hope you understand them. Thanks for watching this video. For know more about the statistics, please watch other videos.